I'll be going over the umpire process for find minimum and rotated sorted array. So for the understand step, so we're given, for the input, we have an array of length n, sorted in ascending order. So we have an array of length n that was rotated between 1 and n times. And then it's a sorted array nums of unique elements, 1 times unique elements, and then so for the output, you want to return, return the minimum element of the array. So for some examples, if we're given, so nums equals 3, 4, 5, 1, 2, we want to return, this is our input, then our output should be 1, because that's the minimum element of the array. Then if we're given nums equals 4, 5, 6, 7, 0, 1, 2, we want to return 0. And then if we're given nums equals 11, 13, 15, 17, we want to return 11. Okay, so for matching, I don't think I've seen this problem before, but I have seen similar problems where you find the minimum element in an array, but I don't think I've seen this exact rotation problem before of an array. And then, I've been working on this problem for a little bit, so the problem asks us to write an algorithm that runs in O log n time. So we wouldn't really be able to use the approach of like using a loop and then trying to find the minimum element that way, because that would be O of n, I think, in terms of time complexity. So for an O log n solution, we'd have to use binary search. So using binary search, right? Using that algorithm. So yeah. So for the plan, so I would, create the left and right variables. I use left and right. So left is these are our indexes. So we're looking at the left index and the right index of the array. And then so we use a loop that goes while left is less than right. Then we look at the we get the middle index of the array. Then we want to check. Then we want to check if that middle element is greater than the last element of the array. If it is, that means our minimum element is on the right side of the array. Because like in this problem, like I think 7 would be the middle element, right? And it's greater than 2, so that means that our array was rotated a number of times where the minimum element should be on the right. I think that goes for this one too, right? Like we have 5, So then that means 5 is greater than 2, and then 1 is our minimum element, so that would work here too. So that means the array was rotated a number of times where our minimum element is on the right. Then otherwise, so we'll do another trick. Otherwise, if our middle element is less than or equal to the last element in the array, it means our minimum element is either the middle element or on the left side of the array. Left side of the array. Yeah, I think that might work here. So we do 0 plus 1, 2, 3, 4 plus 3 divided by 2. So let's see, 3. So that'd be 3 divided by 2. I think that comes out to 1, right? So we'd be here, it'd be a 1. And then this one is less than, so it means that that our minimum element is either this element or it's to the left. And then we know it's to the left, so then we go through the array again. So so this one becomes our right. So it means our minimum element is either the middle or middle element or on the left side of the array. And then we have then we make our right variable equal to the middle, and then we just keep checking. So we do the mid again, so 0 plus 1 divided by 2, I think that's 0, so we probably look at this one, I believe. 0 plus 1 divided by 2, yes, it's 1 divided by 2. And then we're using integer division, so that should be 0. And then let's see, that's 0. So then we're looking at this element. So if we're checking if that middle element is greater than the last element in the array, it's not greater. And then so otherwise, if our middle element is less than or equal to the last element, so it's less than. And so our right variable will equal our middle, like our indexes. So right will be 0, and then while left is the loop when it goes, while left is less than right. And then so you'll have left equaling 0. And then we return the element at the index. And then so we just return the element at that index. Okay, so let's go for implementing it. So we have left equals 0, right equals then nums minus 1, and then while left is less than right, while left is less than right, we look at the middle. So middle equals left plus right divided by 2. And then if mid is greater than nums, or no, if the element of the middle element, nums mid, is greater than the element at the end, so nums right, then we it means our minimum's on the right side of the array, so we update left to equal mid plus 1. Otherwise, it means that either our middle is the minimum or it's on the left side of the array, so then we have right equal mid. Then we just want to return the minimum element, which should be our left variable at this point by the end of the loop. So I run it. Yeah, so I was able to get all 3 test cases, and I'll submit. Yeah, so I was able to get it, nice. And then finally, in terms of evaluate, I believe in terms of time, this is O log n, because every time we run the loop, we're cutting the space of like what we're looking at in half. So that becomes like an O log n solution. And then in terms of space, I believe this is O1 because we use left and right, but those variables, like the space those variables take up, aren't dependent on our input. So thank you. It's my umpire process for find, minimum, and rotated sorted array.